Today I'm going to cover linkage mapping, and this is going to be a little general at first, and then we're going to go into some more specifics. So in linkage mapping, our basic idea is that we want to find out how far apart two genetic loci are from each other on a chromosome. So we're going to kind of work backwards for this first example, and then we'll do it how we might normally think about linkage mapping with an actual cross. So here, let's say that we've got loci A and B, and they are 10 map units apart. What this means for us is that means that their recombination frequency equals 10%. And we know that a frequency is just the number of one class divided by the total number. And so in this case, the recombination frequency, that's going to equal our number of recombinants, this is going to be in our progeny, divided by our total number of progeny. So that's where we're going to be coming from here. And so the first thing we want to figure out is, what does that mean for our classes of progeny? When we're doing recombination frequency testing, when we're doing linkage mapping, we're typically going to be doing these test crosses where we cross a double heterozygote to a double recessive homozygote. So the same test cross that we talked about in class before. So in this case, we're going to take an individual who is heterozygous at both loci, and you might want to be thinking in your head, how do we generate an individual that looks like this, that has big A, big B on one chromosome and little a, little b on the other chromosome? But we're going to cross them to our doubly recessive homozygote. So our little a, little b, little a, little b. And so what we're going to be looking for is we're going to be looking for recombination events that occur here. These recombination events are going to give us chromosomes that we did not see in our parentals. So now we're going to have a big A, little b chromosome and a little a, big B chromosome. Now we're also going to get back out our starting chromosomes where recombination did not occur. That's going to be our big A, big B chromosome and our little a, little b chromosome. So for these two chromosomes, there is no recombination in either of these two chromosomes. And to generate these two chromosomes, there was recombination. There was recombination between the A and B loci. So when we're looking at our progeny classes, we're going to be looking for these particular chromosomes. So these are all the chromosomes that are generated from this one heterozygous individual, because when we look at our test crosser, this individual here can only produce one kind of chromosome. This individual can only produce the little a, little b chromosome. So let's look to see what's going to happen in this cross. So let's redraw our cross up here. We've got our big A, big B chromosome, and our little a, little b chromosome. And we're going to cross this to an individual who is little a, little b, little a, little b. So all of our progeny are going to be getting this little a, little b chromosome from this parent. So all of our progeny should have that. Little a, little b, little a, little b, little a, little b. So you can see that I already know that we're going to get 4 classes of progeny based on what we did on the last screen. Let me just divide this up here into 4. So we have each of our progeny in its own little square. Okay, so now let's think about what they're going to get from the other parent. Well, we could have the parentals. So these parentals are going to be big A, big B, or little a, little b. These are the chromosomes that they're getting from this parent. They're getting the parental chromosomes. No recombination has occurred. On the other hand, we could also see recombinants. And so these recombinants are going to be our big A, little b, or our little a, big B. So now let's think numbers. Now remember that recombination frequency of 10%, what that tells us is that 10% of the total progeny should be recombinants. So now we're going to say, what if there are 1,000 progeny? So what if there are 1,000 total progeny? How many of these progeny do we expect to be recombinants with a recombination frequency of 10%? Well, 10% of 1,000 is 100. And so we would say 100 out of 1,000 times 100 equals our recombination frequency. So that's going to equal to 10%. So 100 over 1,000. That's going to be 10 map units apart. So we're going to expect for all of our recombinants together, this should equal to 100. And that leaves for our parentals just 900 individuals. Now, each of these two classes of recombinants is equally likely. And so that means for each of them, we should get 50 progeny. So 50 progeny that are big A, little b, and 50 progeny that are little a, big B, little b. For our parentals, if there are 900 total and each of the classes are equally likely, then we expect to get 450 progeny for each of them. And so this is how we can figure out what we expect to see in our progeny classes in terms of genotype for a given cross and a given recombination frequency.